Hello and welcome to Transverse and Longitudinal Waves Part 2. So straight away into the starter, question 1 on your Google Doc. Can you pick the letters that represent the amplitude and wavelength of the wave on the diagram? There are more than one letters that you could use for each. Okay, so we're looking at transverse and longitudinal waves again, but this time we're including frequency. So challenge is to identify amplitude, wavelength and frequency in a diagram of a transverse wave. Hopefully you will have already identified amplitude and wavelength from the starter. And the Aspire outcome is to compare the frequencies of different waves on a diagram. Okay, so here's a representation on a graph of a transverse wave with the vibration up and down on the y-axis and then the direction of travel on the x-axis. So if we were to represent the amplitude on there, the amplitude would be from the equilibrium point where the wave would be if there was no energy in it, so it'd be flat. If you imagine that as a water wave that's flat. So the amplitude is from that point up to the highest point, to the peak. Or you could measure from the equilibrium point to the lowest, the trough. Make sure that you don't measure the full distance, it's only halfway up. And then on the same graph, the wavelength, we could measure from peak to peak or from trough to trough. If you're doing this in an exam question, do be careful that you are putting your arrow to the right place. But you could also measure from that point of a wave to that point of a wave where it starts to repeat itself. Again, just be careful that you don't go halfway. So this wave starts here, it goes up, it goes down and back up to where it started from. So that's one full wavelength. Okay, so let's introduce frequency. So the frequency of a wave is defined in the number of waves passing one point in a second. So if you stood on the beach and one wave passes over your feet in 1 second, that water wave has got a frequency of 1 hertz, 1 wave per second. So that's the unit of frequency, hertz. So the Hertz is named after Heinrich Hertz, German scientist, died quite young, who did an experiment using sparks to produce radio waves. As he did that, he actually proved that all electromagnetic waves exist, and he did a little bit of work with the properties of those waves as well. So I'm just going to have a quick look at the practical work that he did on this video clip. You don't need to know it, but it's quite interesting the way that he did it. So now on the following video clip, I want you to count how many waves pass the red line in 10 seconds. So we've got two little dippers dipping in this water, so it's producing a water wave. It's frozen at the moment. Right, I'll get the clock up. Now, you can see the red line there. What I want you to do is to count the number of waves that are passing that red line there in 10 seconds. Okay, so if you start counting, I'll give you 1, 2, 3. So count them as they're crossing and use the clock there just to record 10 seconds. Pick any 10 seconds that you want and count the number of waves that pass that red line in 10 seconds. And I'll just give you a little bit of time to get on with that. Okay, if you write that down, so for question 2, write down how many waves you got in 10 seconds. And for question 3, I want you to do a little bit of maths and tell me how many waves that would be in 1 second. And remember, that number that you write for question 3 will actually be the frequency of the wave, because the definition of frequency is the number of waves in 1 second. I'll just give you another 30 seconds to do that. Right, so this little video clip is done by Mr. Marcy at Outward Academy Acklam, who's talking you the frequency of a wave and some calculations. So I'll let this run. There's some questions at the end that you'll have to pause the video for.
Hello and welcome to video number 3 in this series on waves. In this video we are going to focus on the frequency of a wave. We're going to look at what frequency is. We're going to look at how to identify the frequency of a wave from a frozen wave diagram. We're going to look at what the units of frequency are, and we're going to dive a little bit deeper and we're going to explore the relationship between frequency and wavelength of a wave. So before we start, it's really important that we recall the key information that we have covered so far. So I'm going to pop a retrieval grid on the screen now, and what I'd like you to do is pause that, answer those questions the best you can, and then unpause the video and the answers will be revealed to you. Okay, so let's get started. So the first thing I said I was going to talk about is what is the definition of frequency. So frequency is the number, let's go right now, of waves per second. Okay, so frequency is the number of waves per second. It's the number of waves passing a point per second. So I've drawn this frozen wave diagram here. And I'm going to put on the 0. So that's the line of zero disturbance, which runs all the way from the middle. And remember, this arrow represents the energies being transferred. And this is a transverse wave. These are the peaks. These are the troughs. This is the positive direction. So when because the thing that we are oscillating is moving forwards and backwards. So we've got the positive when it's moving in the forward direction, and we've got the negative when it's moving in the backwards direction, or the opposite direction. So in order to figure out how many waves there are per second, we have to take our wave diagram and you have to be able to identify one wave cycle. And one wave cycle, so one wave cycle equals one wavelength, which remember that symbol there, lambda, represents wavelength. So we've got to find a wave cycle. And the way you'd find one wave cycle is to find one wavelength. So in the last video, we looked at identifying the wavelength on a wave. If you can't do that, go back to video number 2, which was labeling a wave. But you should be able to see that we could find the wavelength between here and here, or between here and here, so a peak to a peak or a trough to a trough. However, this wave doesn't start with the peak, so we can't start there, and it doesn't start with trough, so we can't start there. It starts here. It starts with a wave on this line of zero disturbance. So we've got to start there. I'm just going to draw these lines back in as best as I can. There we go. So Missed another one. We've got to start here. So if we start here, we're going to looking for the next equivalent point. So we've got, I'm going to put my arrow on here. So we've got here, up, that was going the opposite direction, and then back there. So we've got one wavelength here, one. So I'm just going to draw that there. So we've got one wavelength. And then we start again here, and we're going to there. So we've got two, here to here, three, and here to here, four. So this wave shows 4 full wave cycles, 4 wavelengths. Now, if we were told that this frozen wave diagram represents 1 second, so in 1 second, all of these waves would travel past this point. So there would be 4 complete waves in 1 second. So I'm going to say 1 second. It makes it very easy to find out the frequency, because the definition of frequency is the number of waves per second. And if we've got 1 second here, so to that very end of that wave, and we've got 4 wavelengths, so we've got 4 wavelengths in 1 second, then we know that it is 4. The frequency is 4, and the units are hertz, Hz, or you can write it hertz, like that. Okay, so I'll say that one more time, so that you just count the number of wavelengths. So you have to be able to identify them, and you just look at how many seconds that's taking course over. So in this case, 1. So there would be 4 waves in 1 second, which is a frequency of 4. Let's have a look. Let's change this. So let's say that there are still these 4 waves, but this was 2 seconds. So we've got 4 waves in 2 seconds. Now, the definition of frequency says the number of waves per second. So we don't want how many waves per 2 seconds. We want how many waves in 1. So what we're going to do is we're going to divide this to get it to 1 second. So in order to get 2 to 1 second, we're going to divide by 2, which is going to give us 1. And if we divide this side by 2, we're going to divide this side by 2. So 4 divided by 2 is 2. So if there are 4 waves in 2 seconds, there are 2 waves in 1 second. So we've got a frequency here of 2 hertz. Okay. And one more time. Let's say that this wasn't 2 seconds. Let's say that this was 10 seconds. So we've got 4 wavelengths in 10 seconds. We're going to get this to 1 second. So we divide by 10. It's going to give us our 1 second. And we're going to divide this side by 10. 4 divided by 10 is 0.4. So we have 0.4 waves in 1 second. So we've got a frequency of 0.4 hertz. So the final thing that I want to cover in this video is the relationship between the frequency and the wavelength. So I've just drawn 2 traces of frozen wave diagrams, both starting at the same thing. Both I've just put on the line of 0 disturbance, and we're saying that the energy is going from here, going that way, energy is going from here, going that way. And they are both covering the amount of waves that would pass from here to here in 1 second. So I'm going to do 2 waves, but of different wavelengths. So I'm going to draw this one first. And in this one, I'm just going to do another one. Okay, so we can see that in this first wave diagram, I have got 1 wavelength. So 1 complete wave cycle in 1 second. So I've got 1 wavelength in 1 second. So the frequency is 1 hertz. In this one, I've got 1, 2, and 3. 3 waves in 1 second. So I've got a frequency of 3 hertz. So we can see from these 2 diagrams that there is a definite relationship between the wavelength and the frequency. And the relationship is this: the longer the wavelength, the lower the frequency. Or the shorter the wavelength, the higher the frequency. To check your understanding, have a go at the questions on this slide. Just pause it and take however long you need.
Thank you, Mr. Marcy. So just in quick summary then. So got a graph again, height up the side, +1 metre, plus 2 meters, and then -1, -2. And then we've got the time along the y-axis, half a second, 1 second, 1.5 seconds, 2 seconds. So if we put a wave on there, let's call this wave A. So wave A, so let's find one full wave, starting at the beginning. That's one wave we've got there in 1 second, and then another wave in 2 seconds. So we've got 2 waves in 2 seconds. That's the same as one wave in 1 second, as you can see it there. One wave in 1 second is a frequency of 1 hertz. So let's put another wave on. Let's call this one wave B. So wave B, it's got a bigger amplitude, but let's not worry about that for now. Bigger amplitude's going up higher. Just have a look at the wavelength. We've got one wave in half a second, and then 2 waves in 1 second. So 2 waves in 1 second. So that's a frequency of 2 hertz. So wave B has got a frequency twice that of wave A, which means that its wavelength is half. So it's squashed up into half the distance. So on your Google Doc then, I want you to find the frequency of wave C on the diagram. Remember the frequency is the number of waves in a second. And then I want you to find the frequency of wave D on the diagram. I'm just going to give you 2 minutes. Let's introduce frequency and sound. So we often refer to the frequency of a sound wave as its pitch. So that's the term that we'd use in music. So high-pitched sounds are sounds that have got high frequency, and low-pitched sounds are sounds that have got a low frequency. So we've just got a little video clip here, and it will increase the frequency of sound and represent the sound wave as a transverse wave on the screen. And just be careful, be in control of the volume. You might find it gets a little bit painful. You might also find that the low-pitched notes might not come out of your speaker. It just depends on the quality of the speaker that you're listening on. So now complete the rest of your questions on your Google Doc. The last two questions are GCSE exam questions. So have a look how many marks that they're worth, and each mark should take you about a minute. So keep an eye on the timings as well. So good luck. Don't forget your plenary quiz, and you should get feedback straight away on this. So there's a wave goodbye, but it's not goodbye from Waves. See you next time.